So this is the second part of the review, and this is where we'll do what you mostly did in grade 10, and that's using trigonometry to find um, angles and sides. But I quickly want to go back to what we just finished on with the cosine of 60 is 0.5 and the tan of 50 is 1.19, and I got these numbers from your calculator. So what you have to have in trigonometry is a calculator. So I just want to show you where those numbers came from because it's simply pushing a button. What you'll see on your calculator, doesn't matter what kind, you'll see a sine button, a cosine button, and a tangent button. And these are things that they're a program. So when you punch one of those buttons, the calculator automatically thinks of an angle and a side, and it gives you a number that tells you, how big one side is compared to another side. So in the cosine of 60 degrees, all I did to get the 0.5 was I punched in cosine 60 and then I hit enter, and there's my there's my 0.5. When I punched in the tangent of 50 degrees, my calculator told me 1.19 blah blah blah. So we didn't talk about that. We're going to talk about it in the future, and I just wanted to remind you. So let's go on and do some examples. So the first one we're going to do in this part is simply finding the trig ratios for angle A in the picture to the right. So everything is relative to angle A. So I want you to remember opposite, adjacent, hypotenuse. And the very first thing I would do is I would go ahead and label them. So we always know the hypotenuse is always the hypotenuse, and the hypotenuse is opposite the 90 degree. In fact, the little 90 degree points the way. The easiest with the opposite and adjacent is the opposite. Opposite just is across from. So relative to angle A, this side over here, the vertical side of this triangle, would be the opposite side to angle A, and the only other leftover one is that one, the horizontal side, so that would be the adjacent. So I really suggest you label every one of your triangles and write down the hypotenuse first if it's 90, and then opposite and adjacent. So given that we know these, we can go ahead and fill in the basic sine, cosine, tangent ratio. But what I want you to realize is we don't have the side adjacent to angle A, but we do have something that could really help us. So we're going to use Pythagorean theorem, and we're going to figure out, using Pythagorean theorem, what that horizontal side is. And I'm just going to call it side B. So I'll just call it side B because in my head, that would be angle B and that would be angle C. So Pythagoras says one leg squared plus another leg squared is equal to the hypotenuse squared. And what we're going to do is we're going to expand out all those numbers, and we're going to use our calculator if we need to. And when we subtract 196 from both sides, we're going to get 429. And we take the square root, and we're going to end up with the square root of 429, which is about 20.7. So as soon as we know that, then we have all the information to do the basic trig ratios. So the sine of angle A, again, I don't know what angle A is, I don't care what it is opposite, that's 14, over hypotenuse, that's 25. The cosine of angle A is the side adjacent to, which is 20.7, compared to the hypotenuse. And finally, the tangent of angle A is the side opposite, which is 14. The side adjacent is 20.7. And that's all we want. Now, if we wanted to know angle A, we have more than enough information, and we'd use our calculator and we'd figure it out. But we're going to come to that later. Okay, so let's go through some grade 10 problems. Find all the unknown sides and unknown angles. So again, what you really should get in the habit of doing is labeling your triangle. And again, sides opposite are just the lowercase letters. And in this one right here, I need to figure out two sides, side A and side C, and angle B. And I think the easiest one is angle B. And we know that angle B is equal to 50 degrees because from last unit and before, we know that the interior angles of a triangle add up to 180 degrees. So I know angle B plus 90 plus 40 equals 180, and that's where angle B has to equal 50 degrees. So that one's pretty straightforward. In order to figure out the sides, what I want you to recognize is Pythagoras doesn't work because you only have one side. It doesn't matter what order you do it, so I'm just going to do little a first. So we're going to figure out little a. Now here's what I tell my grade 10 students. Whenever they're doing with trigonometry, you write down what I know or want to know. So that's what WIK stands for. What I know or want to know. And if you write this down, it literally points out what the trig ratio you should use. So what do I know? Well, I know angle A. I know the adjacent side to angle A. Again, adjacent means touching. And what I want to know is the side opposite, and that's side A. So again, in this one right here, I know my angle, I know my side, and I want to know that one. And if I think about SOHCAHTOA, I have opposite, I have adjacent. This little thing points out that I need the tan ratio. And now I just write everything in its place. So we have the tangent. Remember, the tangent's a button on your calculator. It has a pre-programmed idea of what you're asking it to do. The tangent of our angle is 40, is equal to the opposite side, which is A, I don't know it, over the adjacent side, which is 5.4. At this time right now, what you could do if you wanted, and I'm going to do it the first time, but it's up to you. You could literally change tan 40 into the number that the calculator represents. So we'll get out our calculator and we'll just press tan of 40. And my calculator is going to tell me how every triangle that has a 40-degree angle, every right triangle with a 40-degree angle, is going to tell me the ratio of the side opposite to adjacent. And it's telling me 0.8391. I want us to get in the habit of writing to 4 decimal places. So 0.8391 is equal to A over 5.4. So now we have a nasty looking thing, but it really is just a simple equation. And remember what we want to do in a simple equation. We want to isolate the letter, and in this case we want to isolate A, and in this particular example we have to undo a division, and we undo a division with a multiplication, and simply what we're going to do is we're going to multiply both sides by 5.4, and when we do that we get side A, little a, is equal to 4.5 units. And in this case, it's centimeters. So what we want to do is take sides to 1 decimal place, and we want to do angles to a nice number. So what you see in this equation, in solving this equation above, is one of the 3 kinds of equations you only have to solve with grade 10. That's when you have your unknown on the top of a fraction and you always simply multiply over. So that is usually what people would consider the easiest one to solve, but there's actually an easier equation to solve because it's entirely done on your calculator, and we'll look at that last. The next example is the other kind of equation you have to be able to solve, and we'll see what I mean. So now we have to find sine C, and we go through the same side C, and we go through the same idea. What do I know? Well, I know angle A, I know the adjacent side, and little c is the hypotenuse, and what that should point out is the cosine ratio. So in this example right here, given that we have these 2 pieces of information, relative to our angle, we're going to use our cosine ratio. So we have the cosine of our angle, which is 40 degrees, is equal to the adjacent side over the hypotenuse. So here's an example of the other kind of equation we have to be able to solve where the unknown is on the bottom. So I'm going to give you a shortcut because I expect you've done this in your math class already. And this shortcut will work all the time. So first of all, I'm going to get on my calculator, and I've already done this, and I punch in cosine of 40 degrees, and my calculator spits out 0.7660. And again, that's nice because we don't get intimidated by funny words in math. So here's this example right here. Now here's the fast way of solving these equations. We don't multiply over. What we simply do is we change the positioning of these two things. And again, we could talk about that in class, but for right now, I just want to give you the shortcut. So as long as we're happy, and as long as we understand how to solve this particular kind of equation, then we can go ahead and answer this like that. And then I'm going to finish it off. So here's our second kind of equation that we have to be able to solve from grade 10, where the unknown's on the bottom, and we simply interchange it with our ratio on the other side. Okay. So another example, and again, the same basic idea, and the same idea in that, hey, let's label everything. And again, I always want to make the hypotenuse C. So when I label my little sides, they are little a, little b, little c. Just like the example before, angle B is going to equal 29 degrees because we know the interior angle is a triangle. And then all we have is we want to figure out little b and little c. And again, I'm going to use trigonometry because Pythagoras doesn't work. And I'm going to write, what do I know? Well, what do I know? I know angle A. I know the side opposite angle A. So again, here's our side opposite angle A. And what I want to know is that side right there. Now, it's not the hypotenuse. We know where the hypotenuse is. It's the adjacent side. And again, what that does is it points out the tangent ratio. So I'm going to go ahead and use my tangent ratio, and I'm going to plug in my angle, and I'm going to plug in the side opposite, and I'm going to plug in the adjacent side. And again, what I want you to recognize is, just like the example we just did, this is the kind where we interchange these values. So again, I'm going to change tangent of 0.61. I'm going to push that button on my calculator, and here's what I'm going to get. The tangent of 61 degrees is 1.804, and I'm going to plug that into my equation. And even though the numbers aren't nice, it doesn't matter because I'm using my calculator, and my calculator doesn't care. And here's what we end up with. And when we push that button on our calculator, we get 7.9. So we've used trigonometry to determine a side where Pythagorean theorem didn't help. And that's our answer, 7.9. Now, in order to figure out the hypotenuse, well, right now we know the two sides, and we could actually use Pythagorean theorem, but you always want to use the information given in case you made a mistake. If I had made a mistake figuring out little b, then I would use that mistake, and I would be wrong with little c. But before we go ahead and figure it out, we know something about the answer of side C. And what we know is it's the longest side, so we know it has to be bigger than 14.2. So when we do our calculation, we want to double check with this. So let's figure out what trig ratio. Well, what do I know or want to know? I know angle A. I know the side opposite of angle A, and I want to know the hypotenuse. And again, that points out the sine ratio. So our sine of our angle is equal to the side opposite over the side. And again, I don't like sine 61, so I'm going to punch that into my calculator, and I'm going to get my calculator to tell me what the general ratio is. and we're going to use that general ratio to solve this particular triangle. And again, when the unknown is the bottom, we interchange the bottom with the ratio, and we go ahead and use our calculator, and we get 16.2 units, in this case centimeters, which absolutely makes sense, as we said. Okay, so we figured out sides so far, and we figured out angles that are really simple, but trigonometry will also allow us to figure out our angles. In order to figure out angles where we have a ratio or angles where we have a side, it is the actual easiest thing to do in trigonometry because you entirely need your calculator to do it. So when you look at your calculator, it doesn't matter what it is, what you'll see is a sine button, cosine, tangent, but above that you'll see sin -1. So this button right here are the buttons that have the ratio to the -1. These are the buttons that tell us angles. So as long as we have the ratio, or we have the ratio of the sides as a fraction, doesn't matter if it's decimals or a fraction, what this will allow us to do is to simply figure out our angle. And what you simply have to do is press second and the ratio. So in this example, it's second sine. And what your calculator will tell you is it will push that button out. And what your calculator knows to do then is to tell you what angle has the sine ratio of 0.8910. And when we do that, second sine 0.8910, our calculator is going to tell us 62.99, which is 63 degrees. So I don't know anything about this triangle. I just know the ratio of the opposite to the hypotenuse, and if the ratio to the opposite to the hypotenuse is that 8.8910, then the actual angle that we're interested in is 63 degrees. So similarly, if I have the cosine of an angle is equal to 0.1932, in order to figure out that angle, we're just going to press second cos. And as soon as we press second cos, our calculator gives us that button. And what our calculator knows what to do now is to go, okay, when the person plugs in a number, our calculator is going to figure out what the angle is. So again, second cosine, calculator's thinking, okay, the person wants to tell me an angle, and they're going to tell me the ratio of the sides, and I'm going to say, well, that is now 82 degrees. So in this one right here, that angle is 82 degrees. And finally, tangent, same idea. Second, tan, calculator gives us 10 to the -1, 1051. Now imagine I'm going to do this, I'm not going to pull it up again, and when my calculator does that, it will tell me that the angle is 6 degrees.